Okay, let's unpack this. Modern IT infrastructure is, well, it's a sprawling, complex beast, isn't it?
Oh,
We're
absolutely.
talking cloud environments, on-prem data centers,
Yeah.
maybe even edge deployments now.
Yep, all of it.
And trying to manage all that manually is just, it's not just inefficient. It feels like you're constantly fighting fires, battling human error, and costs just spiral,
You really are. It's unsustainable.
which is exactly why infrastructure as code, or IaC,
Mm-hmm.
has become so critical. It's about getting a handle on it all, defining your infrastructure using code.
Streamlining everything.
Exactly. And for the longest time, when you said IaC, one name just dominated, Terraform.
Mm.
From HashiCorp, now part of IBM,
Mm-hmm.
right? It really changed the game for infrastructure management.
It absolutely did. The whole idea of IaC fundamentally is treating your infrastructure like software. Define it in code.
Yeah.
And that gives you huge benefits. More efficiency, way fewer human errors, much more consistent deployments, automation.
Yeah.
And Terraform's approach specifically is declarative. That's
Yeah.
key.
Okay, declarative. So what does that mean in practice?
It means instead of writing scripts saying how to build something step by step that's more imperative, you just declare the desired end state.
Yeah, okay.
You say, I want this network, these servers, this database configuration, and Terraform figures out how to make it happen. You set the destination, it plots the course.
That was a huge shift. Revolutionary, really. But, well, things are changing fast, especially as we head through 2025. The landscape's evolving.
It really is.
So is Terraform still the, the be-all and end-all for every situation? And what does it actually take to master IaC today?
Good question.
That's what this deep dive is all about. We're going to look at Terraform's role now, explore some really interesting alternatives, and distill those best practices you need to level up your infrastructure skills.
Sounds great.
So Terraform, I mean, we have to acknowledge its massive contribution, right? Bringing consistency across clouds, helping so many teams.
Undeniably huge.
But if it's so great, why are we seeing teams rethinking it? From your perspective, what's driving that reevaluation?
Yeah, it's a thoughtful shift, not just jumping ship. Terraform is powerful, no doubt, but as infrastructure gets bigger, more distributed, some cracks start to show.
Cracks like?
Well, a major one is state management fragility. That state file. It's crucial. It maps your code to real resources.
Right. The source of truth.
Exactly. But it can feel like an Achilles heel for teams using Terraform at scale. One wrong move, an accidental delete, a bad manual edit, a race condition during apply. And your whole deployment process can grind to a halt. You could be looking at hours, maybe even days of just trying to recover. Resilience in state management is just paramount. It needs automation, protection.
That sounds genuinely stressful for big teams. A ticking time bomb, almost.
That can feel that way.
Are there other common sort of pain points cropping up?
Definitely. CI/CD integration, for instance. It's not always as, let's say, native as you might hope. Meaning teams often find themselves, duct taping scripts and pipelines together to get their automated Terraform workflows running smoothly. That adds complexity, maintenance overhead.
Right, more stuff to manage.
Yeah. Then there's HCL, HashiCorp Configuration Language. It's designed to be human readable, which is good.
Okay.
But for developers coming from, say, Python, TypeScript, Go, it can sometimes feel a bit awkward, not always intuitive, maybe slows down adoption a bit.
Okay, a learning curve friction point.
Sort of. And of course, we have to talk about the licensing changes. HashiCorp moving to the business source license, the BSL, for versions after 1.5.x.
Ah, yeah, that caused a stir.
It really spooked a lot of open source fans. It brought up real long-term concerns about vendor lock-in, the future.
Right.
It definitely prompted a big community reaction.
Understandable.
And finally, just scaling complexity. As your infrastructure grows, managing all the dependencies, the modules, dealing with potentially long Terraform plan and apply times, it gets tricky.
So what started simple gets complex.
Exactly. For many teams, what began as this amazing time saver now feels a bit like technical debt. It demands significant effort just to manage the tool itself.
It's always fascinating how challenges drive innovation, isn't it? These aren't just annoyances. They've actually spurred a whole new wave of tools, kind of purpose-built for these modern cloud-native setups.
That's right. And this is where the landscape gets really interesting. Lots of options now.
Okay, so let's dive into those alternatives. But maybe first, how should you even think about choosing? Is there a framework?
That's a really good starting point. Just listing tools isn't super helpful without context. You need to consider a few things. First, is it declarative like Terraform or imperative step by step?
Okay, the basic approach.
Yeah. Then, how cloud native is it? Or is it aiming to be cloud agnostic? What about collaboration features? How does it handle state? Is it visible like Terraforms or abstracted away?
Right. State again, always important.
Always.
Yeah.
How smooth is the CI/CD integration? And especially relevant now, licensing and costs. What's the model? Is it truly open source?
And the learning curve, I guess, for the team.
Absolutely. How quickly can your team pick it up and be productive? Those are the key things to weigh up.
That makes sense. Provides a solid way to compare. Okay, so with that framework in mind, what are some of the big players emerging? Maybe start with those that work with existing IaC tools.
Sure. A strong contender there is Spacelift. It's not trying to replace Terraform necessarily, but to enhance it. And not just Terraform, it works with OpenTofu, Terragrant, Pulumi, Kubernetes, CloudFormation.
So it's more of a management platform.
Exactly, a full IaC management platform. It adds things like multi-IaC workflows, powerful policy as code using Open Policy Agent, or OPA.
OPA, okay. What's that quickly?
OPA is a general-purpose policy engine. It lets you define and enforce rules, security rules, compliance rules, naming conventions programmatically across your infrastructure. Very flexible.
Got it. So Spacelift uses OPA for governance.
Right. Plus robust integrations, building self-service infrastructure with blueprints. It's really focused on orchestration, control, and automating the CI/CD for your IaC at scale.
Interesting. And then you mentioned the open source concern earlier. That leads us to OpenTofu, right?
Yes, OpenTofu is a direct result of the BSL change. It's an open source fork of Terraform, specifically from version 1.5.6. It was started by the OpenTF initiative, now under the Linux Foundation.
So proper open source.
Truly open source, no restrictions. That's the main draw. Plus a dynamic community, fast support, minimal risk being part of the Linux Foundation, and features like state encryption built in.
And is it easy to switch?
Initially, yeah, it's designed as a drop-in replacement for Terraform 1.5.x. You can often swap the binary, but the plan is for it to evolve independently over time, add its own features.
Okay, that's a huge development for people committed to open source. Now, changing tack a bit, what about tools that let developers use languages they already know, like Python or TypeScript?
That brings us squarely to Pulumi. And its big idea isn't just using familiar languages, it's about democratizing IaC.
Democratizing. How so?
By letting developers use languages like TypeScript, Python, Go, C#, Java, even YAML, you remove the need to learn another DSL, like HCL.
Lowers the barrier to entry.
Massively. It makes infrastructure management less of a separate ops thing and more of a shared development responsibility. That can really speed up adoption, align infra more closely with app dev cycles.
Makes sense. How does it work under the hood?
It has a language host for the code, a CLI, a deployment engine, and its own state management. And it's designed from the ground up to be cloud agnostic.
Powerful shift indeed. Okay, and then of course the cloud providers themselves aren't standing still. They all have their own native tools, right?
Oh, yeah, absolutely. And they usually offer a couple of flavors. For AWS, you've got CloudFormation. That's the classic declarative using JSON or YAML templates.
Right.
But then you also have the AWS CDK, the Cloud Development Kit. This lets you define infrastructure using familiar languages, TypeScript, Python, etc., but it actually synthesizes CloudFormation templates behind the scenes.
So you get the power of code, but the stability of CloudFormation.
Yeah. Exactly. Best of both worlds, some would say.
And then about Azure?
Similar story. You have ARM templates, Azure Resource Manager templates. Those are JSON-based, very granular control.
Okay.
And alongside that, Microsoft developed Bicep. It's a simpler, domain-specific language specifically for Azure, much cleaner syntax, more readable, but it compiles down to ARM templates.
So again, higher level extraction on top of the core engine.
Precisely. And over in Google Cloud, you've got Google Deployment Manager, often used for predictable compute setups using YAML. And then there's Google Config Connector. This is really interesting. It lets you manage GCP resources using Kubernetes native tools, specifically using CRDs, custom resource definitions.
CRDs. So you extend Kubernetes itself to manage Google Cloud resources.
You got it. You define a GCP SQL instance, for example, just like you define a Kubernetes pod or service, right in your K8s manifests. Brings everything into the Kubernetes control plane.
Wow. Okay. It really is fascinating how each cloud offers that choice, low-level templates for precision, higher-level code for developer speed.
It caters to different needs and team preferences.
So beyond the big cloud providers, what about tools maybe more focused on configuration management or acting as wrappers?
Good category. Ansible comes to mind first. It's primarily a configuration management tool, right?
Yeah.
YAML playbooks, agentless.
Yeah, managing software on the machines.
Exactly. Great for installing packages, configuring services inside resources, often used alongside an IaC tool like Terraform, which provisions the underlying VM or network first.
Complementary tools.
Very much so. Then you have Crossplane. We touched on Kubernetes. Crossplane is fundamentally Kubernetes native IaC. It lets you provision and manage cloud resources directly using Kubernetes-style declarative configs.
So if you're all in on Kubernetes,
Crossplane is super appealing. It treats cloud resources just like Kubernetes resources. And for folks sticking with Terraform but wanting better organization, there's TerraGrunt.
yes, the wrapper.
It's a thin wrapper around Terraform. Its main goals are to help you keep your code DRY. Don't repeat yourself, simplify managing multiple environments like dev, staging, prod, and improve how you reuse modules. Still uses Terraform underneath.
Makes Terraform more manageable at scale, essentially.
That's the idea. And finally, you're seeing newer platforms emerge too, like Northflank and Envy.
What's their angle?
Northflank is interesting. It's a full platform built on Kubernetes that tries to abstract away things like Terraform state and even YAML complexity. The focus is purely on developer velocity, shipping apps faster, managing deployments, databases, CI/CD, without worrying about the underlying IaC state files.
Higher level abstraction again.
Right. And NV is more of a governance and automation layer for your existing IaC tools. Terraform, Pulumi, TerraGrunt. It helps manage environments, costs, policies across the organization.
Okay, wow. The landscape is definitely rich, maybe even a bit crowded now. Which brings us back to that crucial question. With all these options, how do you actually pick the right tool for your team, your goals, your specific technical setup? It's not trivial.
Not at all. It requires careful thought.
So we've explored the tools, the landscape,
Yeah,
but a tool's only as good as how you use it, right?
absolutely. Craftsmanship matters.
True mastery of IaC isn't just picking the right software. It's about the mindset, the practices. So how do we take all this knowledge and actually apply it? How do we build infrastructure that's genuinely resilient, well-managed?
Okay, this is where the rubber meets the road.
Exactly. Let's dive into those essential best practices for IOC in general, and then maybe drilling down into Terraform specifics.
Sounds good. Let's start broad. Fundamental IaC practices, regardless of tool. Number 1, treat your infrastructure configuration exactly like application code.
Meaning version control.
Rigorous version control, yes. And embracing a GitOps approach.
GitOps. Explain that quickly.
Basically, your Git repository becomes the single source of truth for your infrastructure. All changes go through Git, triggering automated pipelines to deploy. It ensures everything is versioned, auditable.
And prevents manual cowboy changes.
Precisely. Actively prevent manual changes that cause drift between your code and reality.
Okay. GitOps. What else?
Second, foster collaborative IaC. Make it easy for teams to use. This means things like self-service infrastructure options, consistent policies enforced everywhere, and giving relevant insights to everyone involved. It shouldn't be siloed.
Those sound like solid pillars. But let's be real, getting teams to actually do GitOps consistently, for example, that can be a cultural challenge, can't it?
Oh, definitely. That's a keen observation.
What's a common hurdle there?
I think one of the biggest is overcoming the sheer comfort of manual changes. People are used to SSing in, clicking around a console.
The quick fix temptation.
Right. Shifting to a code-only, Git-driven workflow requires trusting the automation, committing to code reviews for infra changes. It's a mindset shift as much as a technical one. You have to build that trust.
That makes a lot of sense. Okay, so those are the fundamentals. Now let's get into some specific Terraform best practices, things you can apply to your projects right away.
Okay, Terraform specifics. First and foremost, remote state management. Local state is fine for playing around, but for any real team project, you need a shared remote backend.
Like S3 or Terraform Cloud.
Exactly. AWS S3 with versioning enabled, Azure Blob Storage, Google Cloud Storage, Terraform Cloud. Crucially, choose a backend that supports state locking.
Why is locking so important?
It prevents two people or two automation jobs from running Terraform apply at the exact same time and potentially corrupting the state file. It ensures only one change happens at once.
Avoids race conditions.
Yes, and treat your state as immutable. Avoid manual Terraform state commands unless absolutely necessary, and even then, with extreme care.
Got it. Remote state with locking. What's next?
Leverage modules. Seriously, before writing your own code for, say, a VPC or a database, check the Terraform registry. There are thousands of shared community-tested modules.
Dave's reinventing the wheel.
Immensely. Saves time, ensures consistency. If a good community module doesn't exist for your specific need, then build your own custom modules for reuse within your org. It's not just about cleaner code, it's about speed and reliability across your entire infrastructure. Fewer errors downstream.
Makes sense. Reuse good patterns. How about keeping the code itself clean? Configuration hygiene.
Super important. First, avoid hard coding variables. Use input variables, use data sources to fetch things dynamically, like don't hard code your AWS account ID. Use the Oscalar identity data source.
Keep it dynamic.
Right. Also, use the built-in tools. Terraform FMT to format your code consistently. Terraform validate to catch basic syntax errors. Automate these in your CI/CD pipeline.
Okay, formatting and validation.
And consistent naming conventions. Use underscores, use singular nouns for single resources or variables, make names descriptive, and tag everything. Tag your resources consistently for cost allocation, management, automation. It pays off hugely later.
Tagging discipline. Often overlooked.
Very often. And one more hygiene tip. For really important stateful resources like databases, use the lifecycle block and set prevent destroy a true.
Ah, a safety net against accidental deletion.
Exactly. A crucial safety net.
Okay, moving on to governance and security.
We mentioned policy as code with OPA earlier. That's key at scale for enforcing rules. But also the golden rule of secrets management. Never, ever store secrets in plain text in your code or commit them to Git.
Please don't do that.
Please don't. Use a dedicated secrets manager, HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, GCP Secret Manager. Fetch them dynamically at runtime.
Critical point. And testing. How do you test IaC?
Good question. It's vital. First level.
Yeah.
Always run Terraform plan and review the plan before applying, even locally.
See what it's going to do.
Yes. Then integrate static analysis tools into CI/CD. Tools like tflint. Check for potential errors, bad practices. Check off checks for security misconfigurations.
Catch things early.
Exactly. And for deeper validation, you can use integration testing frameworks like Terratist from Gruntwork. These actually spin up real infrastructure, run tests against it, and tear it down. More effort, but higher confidence.
Okay, layers of testing. How about making the code itself more reusable and flexible?
Terraform has great features for this. Use count for conditionally creating resources. Use for each to iterate over maps or sets, much cleaner than count for creating multiple similar resources based on input data.
For each is generally preferred now, right?
Generally, yes, it's more explicit and handles changes better. Also, leverage Terraform functions for manipulating data and use dynamic blocks within resources to keep your code DRY. Don't repeat yourself, especially for things like nested security group rules or firewall rules.
Making the code adapt without repetition.
Precisely. Finally, let's talk operational excellence. Running Terraform day-to-day.
Okay, the practicalities.
Always plan first. Always review the Terraform plan output, even if you think it's a tiny change. Discipline. Execute Terraform through automated CI/CD pipelines, GitHub Actions, GitLab CI, Jenkins, Spacelift, Terraform Cloud, whatever you use. Ensures a consistent execution environment.
Avoid, it works on my machine.
Exactly that. For credentials in CI/CD, avoid downloadable keys. Use service account credentials, ideally via workload identity federation if your cloud provider and CI system support it.
Explain workload identity federation briefly.
It lets your CI/CD job exchange a short-lived token from its own identity system, like GitHub Actions, for temporary cloud credentials without needing any long-lived secret keys stored anywhere. Much more secure.
Ah, clever. No static keys.
Right. Also, avoid manual Terraform state modifications as much as possible, and be very cautious about using Terraform import to bring existing, manually created resources under Terraform control. It can be done, but plan it carefully.
Import needs care. Yes. And lastly, regularly review your version pins for Terraform itself, for providers, for modules. Use tools like Dependabot to get notified of updates and stay current with bug fixes and improvements. Don't let things get stale. Wow, okay. That's a comprehensive set of practices. It really highlights that using Terraform or any IaC tool effectively isn't just about writing the code.
Not at all. It's about the whole life cycle.
These practices, they aren't just for, technical neatness. They're fundamentally about reducing risk, increasing your deployment speed, making collaboration easier, and ensuring consistency across everything. They're really the difference between infrastructure chaos and infrastructure control.
Well said. That's exactly it.
So what a journey. We've gone from understanding Terraform's foundational role, looked at why it's being reevaluated, explored this really diverse landscape of alternatives, and now landed on a practical toolkit of essential best practices. It's been a real deep dive into modern IaC.
It has. And remember, knowledge like this is most valuable when you actually understand it and then apply it. There's always more to learn, different perspectives, always rich understanding. Critical thinking is just so important with all the information out there.
Couldn't agree more. Terraform was absolutely a groundbreaking innovation, a true game changer. But the infrastructure game has evolved. The world's moved on.
It keeps moving.
So before you just jump ship and
Yeah.
swap one IaC tool for another, maybe take that step back. Ask yourself, what do you actually want from your infrastructure automation? Is it simplicity? Is it raw speed? Is it reducing that operational overhead we talked about?
What's the real goal?
Exactly.
Yeah.
What's the next practical step you are going to take to really optimize your infrastructure automation workflow? Something to think about.